Friends, good afternoon. Uh, in the first class of electrostatics, we have gone through some concept. The most important concept which we studied at that day, I'm going to recap it. This was Coulomb's law. According to Coulomb's law, if there are two charges Q1 and Q2, they will feel either the force of attraction or force of repulsion, and the value of the force is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. So here we should understand something. If Q1 and Q2 are of same nature, then the force will be repulsive, and if Q1 and Q2 are of opposite nature, then the force will be attractive. Now, this can be written in another way. If I'm writing Q1 into Q2 greater than 0, it means if Q1 is positive, then Q2 must be positive, because their multiplication is greater than 0. It means that their multiplication is positive. And if I'm writing Q1 and Q2 is less than 0, it implies that if Q1 is positive, Q2 is negative, and if Q1 is negative, Q2 is positive. Here, if Q1 is negative, Q2 must be negative. So in this case, the repulsive force will be there. So they will repel, and here they will attract. Now, we start with today's class topic, that is theory of superposition. Theory of superposition means when an electric charge is surrounded by two or more charges, more than two charges, then the net force on the charge will be the vector sum of all the forces experienced by it. See, here I'm going to take a charge Q. This is the charge which is surrounded by charge number 1, Q1, charge number 2 minus Q2, charge number 3 plus Q3, charge number 4 minus Q4. And they are at the distance R1, R2, R3, and R4. So if we discuss here, they will feel this charge Q will feel the force F1, F2, F3, and F4. So the net force on the charge will be equal to the vector sum of all the forces experienced by it. We all know, we are aware of the vector concept. The force is a vector quantity. So when we are going to add all the forces, we have to follow the rule of vector sum. And at that day, I have discussed how can we solve the vector sum. There are two methods. Number one, log parallelogram, which is for two charge system. And if there are more than two charges, then we have to go for resolution method. Let us see one example. I have taken one example. What are the horizontal and vertical components of the net electrostatic force on the charged particle in the lower left corner of the square which is shown in the figure. If Q is equal to 1 into 10 raised to power 7 coulomb and A is equal to 5 centimeter. So if we are going to solve here the numerical, we have to show at first the direction of the forces, because here are four charges and we have to choose the charge which is on lower left corner. That means this one. So I'm going to consider the charge here which will have the value plus 2q. Now this is surrounded by a charge minus 2q here, a charge minus q here, a charge plus q here. So at first we have to see, you should remember that in our previous class we have gone through, whenever we have to solve the problem, we have to follow some certain steps. The step was that, the first one was show the direction of force. The direction of forces. And then calculate the value of forces. Value means magnitude. And then resolve the forces. Along x-axis and y-axis. And then finally, net force is equal to under root total x component square plus total y component square. So here, if I'm going to take this, part to solve here, we can see, sorry. If we solve this numerical here, we can say that this is the point charge where we have to find the value of force or the desired thing which is asked in the question, horizontal and vertical component. This is minus 2q. So at first we have to see if minus 2q is here, plus 2q is here, where does this plus 2q charge will move if this minus 2q will come into account. So we can say that this is minus and this is plus. So this minus charge will attract this one, and that's why this will move in this direction. And hence, this will be the direction of force. You can say F1. Now, when we are going to take minus q, again, we have to draw a line meeting plus 2q and minus q, and then the direction of force on plus 2q will be attractive. That means towards minus q. Say this is F2. And then if you have chosen plus q charge, then the direction of force will be repulsive, and hence plus 2q charge will move out, and this one will be F3. So we have shown the direction of all the three forces. This was, or this is our first step. Now in second step, we have to calculate the value of forces. F1. By Coulomb's law, the value of the force is 1 by 4 pi epsilon naught Q1 Q2 divided by R square. As I have told you earlier, that you should not take care of sign when you are calculating the magnitude of the force. So I'm going to put the value 1 by 4 pi square, 4 pi epsilon naught is 9 into 10 raised to power 9. This was discussed at the day. Now, Q1 is what? This one can be taken as Q1. This one can be taken as Q2. And hence, it will be 2Q into 2Q divided by distance is square, and distance is 5 centimeter. So you can write it 0.5 whole square. So we can say here the value of the force is 9 into 10 raised to power 9 into 4 into Q square divided by 5 centimeter means 0.05, not 0.5, 0.05 square. It means here it will be 25 and here it will be 10 raised to power minus 4. So the total value of the force will be 9 upon 25 into 4 into 10 power 5, 9 here and minus 4 here into Q square. So this is the value of 36 divided by 25 Q square into 10 raised to power 5 Newton is the force, first one, F1, say equation number 1. Now, when we calculate the force value 2, we have to write 9 into 10 raised to power 9 into plus 2Q means 2Q and minus Q, it means Q, because we have not to take plus and minus into account, divided by R square means 25 into 10 raised to power minus 4. And that becomes 9 to the 18 divided, this value of the side, this one, will be what? A root 2. So when I'm going to write here, it can be 0.05 root 2 square. And then it will be here 9 to the 18 divided by 25 to the 50 into Q square into 10 raised to power 5 Newton. And again, when we are going to calculate F3, the value of force will be 9 into 10 raised to power 9 into 2Q into Q divided by 0.05 whole square. And that becomes how much? 18 Q square, 18 Q square divided by 25 into 10 raised to power, sorry to say, here will be plus. So here will be 9 and 5, not 5. It will be 14. 9 and 5, 14. Here will be 14 again. Here will be 14 again. Look, why it should be 14? Because this is 0.05. So in denominator, there will be 10 raised to power minus 4. That will go up and that will be 10 power 4. So not 14, 13. How much it will be? 13, 13, and 30. Now, the main problem is how can we solve afterward? So see here, this force is in this direction, this force is in this direction, and this force is in this direction. So when we are going to take, we have to draw the geometrical axis, x-axis, y-axis, or you can say horizontal axis and vertical axis. Then you can see here the F1 is along positive x direction. So we can write it here that this is F1. Okay, now where is F2? F2 is in this direction. So I'm going to put it here. This is F2. And in which direction there is F3? That is downward. Minus here is F3. Values are clear to you. Now, this is along positive x-axis. This is not either along for x-axis or y-axis. And the angle value will be 45 degree because this is a square. So we can say that this angle is 45 degree. So its component will be here in this direction. It will be F2 cos 45. And in this direction, this will be F2 sine 45 degree. So once it is resolved, it is broken, this can be omitted, this can be cancelled. So initially we have three vectors, three forces. After resolution, we have four, because one vector, that was second force, is broken into two parts, one along x-axis, one along y-axis. Now, when we are going to calculate the total x component, the total x component or horizontal component, we can write fx is equal to f1 plus f2 cos 45 degree. And what was the value of f1? You have calculated it here. 36 upon 25 q square into 10 power 30. It was 36 upon 25 q square into 10 raised to power 30 plus, what was the value of f2? f2 is equal to 18 by 50. 18 by 50 q square into 10 raised to power 13. And what is the value of cos 45? It is 1 by root 2. So when you sum them, when you add them, it will be 36 upon 25 plus 18 divided by 50 root 2 q square into 10 raised to power 13. This is in Newton. Now, when we calculate y, you can see the f2 sine 45 is in upward direction, and that will be taken positive x, positive y, and that's why that will be written as plus f2 sine 45 degree. And f3 is downward, so it will be towards negative y-axis, and that's why it should be taken minus. So value of f2 is known to you. It is 18 by 50 into q square into 10 raised to power 13 into sine 45 means again 1 by root 2 minus, what was the value of F3? It is 18 by 25. So minus 18 upon 25 q square into 10 raised to power 13. So when we do it, we can take 18 by 50 minus, 50 root 2 minus 18 by 25, and then q square into 10 raised to power 30. So this was the answer. This is answer what was asked to you. What is total horizontal component? So this is your total horizontal component. Putting the value of q square and doing, division solve, we can get the answer. And this is what total y component is square. No. So this is the theory of superposition. So if anybody is having a doubt regarding this theory of superposition, you may ask, please. Anybody, if you are having doubt? No. Let me have a look who are here. How many? 1, 2, 3 are there. Sham, do you have any doubt?
No, sir.
So you are getting all the things which I'm telling you?
Yes, sir.
Okay. Now, the next topic is electric field. This is one important topic, electric field. At first, we should know about its physical appearance, physical significance, and then its numerical value. Suppose I'm going to take a charge. This is a charge. This charge is taken by me and I'm putting another charge, any charge. Suppose I'm taking a charge here and I'm saying that this is positive charge and this is positive too. So we can say that this charge, this very charge, will repel this charge. That means this charge will experience a force due to this one. If I'm saying that this is first charge, this is second charge, so we can say that the second charge will experience a force due to first charge. So electric field is what? Can we define the area, the region, the range up to where this second charge will experience the force? So up to where the second charge will experience the force due to first charge is called electric field of the first charge. So simply we can say कि जो इलेक्ट्रिक फील्ड है वो किसी भी चार्ज के चारों ओर का a reason is that in which if we place any other charge, it will experience either the force of repulsion or the force of attraction. So if we can write the definition, physical definition of electric field, we can say that here the reason around any charge in which any other charge experiences the force of attraction or repulsion. Okay, now we are coming on its numerical value, and the numerical value of electric field is called strength of electric field. Strength of electric field. Sometimes this is also called intensity of electric field. Okay, so how can we define it? One thing I want to add, in previous slide, I can see that this charge that is producing the field is called source charge. This one is called what? Source charge. And due to which charge we are able to detect the electric field is called test charge. So, and test charge should have some, special character. It is always taken, always positive. Now, we are coming on definition of electric field, or intensity of electric field or strength of electric field. You can say that intensity of electric field is defined as the force of attraction or repulsion on unit positive test charge. Suppose I'm saying you that I'm taking a source charge Q and I'm taking a test charge Q naught, and I'm I have told you that the test charge should be positive always. I'm taking this one is positive too. So when we place a test charge, I'm writing that this is which kind of charge? This is source charge. And this one is test charge. So when you place test charge nearby a source charge is still positive. Test charge is also positive. So test charge will feel a force of repulsion. And I'm going to say that this force is F. So by the definition, the electric field intensity or the intensity of electric field is the force on unit test charge. That means the force on unit test charge, means take a ratio, will be given by electric field intensity, and the symbol of electric field intensity is E. You can say given by E. So E is equal to F upon Q naught. And you all are aware that force is a vector quantity. So if you place a vector notation over F, you have to place a vector notation over E2. It means electric field intensity is a vector quantity. Why is it vector? Because F is vector. And Q naught is what? Scale. Now, if this is the formula, with the formula, can we calculate the unit? So if I'm going to say you calculate the unit of electric field, what can you say? The unit of E will be unit of F divided by unit of Q naught. So when we write the unit of F, it will be what? Newton. When we write unit of Q naught, it will be Coulomb. And that's why the unit of E will be Newton per Coulomb. So any doubt regarding your, how many of you are? Sam, do you have any problem?
Yes, sir.
Anybody else? I'm unmuting you all. If you have any doubt, you can ask the question. If you have any doubt, you can please. No doubt at all.
अपलोड कर देंगे तो जूम करके क्या क्या होता है, लेकिन जूम करने से भी बोलते हैं ऊपर नीचे का भी कटेगा। हमको तो साइड कटना है बस। देखते हैं सीन क्या है।
Hello. So we are coming to the next topic, that is electric field due to a point charge. When we discuss about point charge, we can say the charge is given to a body which is like a point. So our source charge is a point charge. I'm placing it here and I'm considering the value of the charge is Q. And we have to find out the intensity of electric field at a point P, which is situated at distance R from the source charge. So when we have to calculate E, we have to calculate the value of F. So at first we have to place here a test charge Q naught plus Q naught, you can say, and then the Q naught will experience a force in this direction because I have taken the source charge positive, and this will be F, that is towards this direction. So the value of F can be calculated. 1 by 4 pi epsilon naught Q by R square. This is by Coulomb's law. Now, as per definition of E, electric field, E is equal to F upon Q naught. So if I'm writing it here, 1 upon Q naught into putting the value of F, we can write Q naught divided by R square. Q naught will be cancelled. So E will be 1 upon 4 pi epsilon naught Q upon R square. So this is the electric field intensity of a source charge Q at the distance R from it. And this is only its magnitude. Where will be the direction? If source charge is positive, then field will be away from it. And if your source charge is negative, then E will be towards it. So we can say if I'm going to represent it in a vector form, I can write it in this way. Vector E is equal to 1 by 4 pi epsilon naught Q upon R square. And if I'm taking it a vector, here will be the unit vector R cap, and that's why here we can write R cap. So it will be 1 upon 4 pi epsilon naught Q upon R Q and then vector R, because we can write R cap is equal to vector R divided by mod of R. So this is the value of electric field intensity due to a point charge. So two important facts we should note here, that what will be the value of electric field? Commonly, its value is E is equal to F upon Q naught. But if we are taking a point charge, then its value can be written in the form E is equal to 1 by 4 pi epsilon naught Q upon R square. Now, we have to be very careful about the direction. If your source charge is positive, then what will happen? If your source charge is positive, the direction of field will be away from the source. And if your source charge is negative, your E will be towards it. So clear? Now, since your electric field is generated or obtained from your force formula, and that's why the theory of superposition, as we have discussed earlier, that this is followed by force. So the theory of superposition is also followed by electric field. So I'm going to take one example. I'm going to take a triangle, and suppose this is a triangle of equal side, equilateral triangle. I'm going to take the three charges here. One here of Q, one here of Q, one here of Q again, and I'm asking you, what is the value of electric field at its center or centroid? So at first, you have to decide where is the point where we have to find the value of E. We have to say, what is the value of E at this point? I'm taking it as O. I'm taking the three corners of the triangle as ABC. So when we are going to solve such type of numerical, again we have to follow the same steps. At first you have to show the direction, and then you have to find the values of forces, not forces, here the field you can say. And then resolution. After that, total X and Y components. And finally, net electric field. So, at first we have to decide what is the direction of the charge placed at point A. So here is plus Q. If no sign is given to a charge, it should be considered as positive. So plus is here. So it's the direction of the force will be, field will be away. Away means this way. This way. Away from the source charge. Now, if I'm taking the charge Q on B, again this should be taken to be positive, and hence at point O, the field will be away from the source. Now, when we take Q here at point C, the same way this should be positive and the direction will be here. So I'm going to write it as E1, this one is written as E2, and this one is written as E3. So direction is shown by us. Now, we have to find the values of the fields. So when we are going to find the values of the field, we have to write E1 is equal to, let this distance is R. So the centroid of a triangle have the same value. Okay, so when we write here E1 is equal to, you know that this is a point charge. So 1 by 4 pi epsilon naught q divided by r equals what? You can say direction to आपने show कर दिया. You have shown it there. So no need of writing here, because you have mentioned here only scalar format, only the numerical value. E2 will be what? 1 by 4 pi epsilon naught again q by r square. Now E3 is what? The same way here, 1 upon 4 pi epsilon naught q divided by r square. So you can see here all the three values of the electric fields are same, but their directions are different. So when we are taking, we have to take it, you have completed this step, now we are coming on this step, resolution. And for resolution, we have to draw one axis x, one axis y, and then we have to show the direction of fields here. One is, E1 is in this direction, E1 is in this direction. So this is E1. Now, E2 is in left direction here. So this is E2, this is E1, this is E2, and this one is E3. So during resolution, we should be very careful that किसको हम break करें और किसको नहीं. So जो vectors are the vectors who are either along x-axis or along y-axis, they will be taken as such. But those vectors who are not along x or y-axis, we have to break them. Now, see, if this is equilateral triangle, then this total angle will be 120 degree. And here again, this total angle, this one will be 90 degree. Simply you draw a line here, and then this angle will be 30 degree because the whole one will be 60. So this one is 30. So here this angle will be 30 degree, this angle will be 30 degree. And now the resolution works goes on. You can resolve it here. It should be E1 cos 30 degree, and here will be E2 cos 30 degree. Now in this direction, here will be E1 sin 30 degree, and E2 will have also its vertical component in the same direction. So E2 sin 30. And now the thing that the vectors who are resolved will be omitted from there. So these are not, now in the scene, in the picture. Now we can say the total x component of Ex will be what? This one will be positive because this is towards positive x-axis. So it will be plus E1 cos 30 degree. And this one will be taken minus because this is towards negative x-axis. So minus E2 cos 30 degree. And that's why you know that E1 is equal to E2 cos 30. So they both will be same and their subtraction will be 0. So total x component is what? 0. Now we are coming on total y component. When we are going on y component, we can write here what? For plus E1, because this is plus y-axis, and so plus E1 sine 30 plus E2 sine 30 minus E3, and sine 30 means half, so E1 by 2 plus E2 by 2 minus E3. And you know, E1, E2, E3 are same. So if I'm writing E1 as E3, then E3 by 2 plus E3 by 2 minus E3. And you know, the value will be 0 again. So total X component and total Y component will be 0. So what will be E net at that point? E net will be under root, what will be 0 square plus 0 square. As you are aware of that, we should write here all X component is square plus all Y component is square, and that is 0. So what is the net electric field at this point O or centroid? That will be 0. So many questions are there in your textbook, NCERT textbook. You can solve it from there. There are the questions on square, hexagon, triangle. Now one question can be solved, okay. I'm taking one charge here of minus 3 microcoulomb. One charge is taken here, that is plus 3 microcoulomb. And the distance between them is 2 meters. Now, this is its midpoint. I'm going to take a point here, P, which is situated at distance 6 meters from the center O. This is A, this is B, and this is P. So the distance from here to here is 6 meters. And this O is the midpoint. So you can say that from A to O, it will be 1 meter. And from here to here, it will be again 1 meter. If I'm asking what is the electric field at point P, what to do? At first you have to show the direction, then calculation, then resolution if there are more than 3 electric fields. So अभी तो मेरे पास अगर मैं देखूं तो मेरे पास सिर्फ 2 charges हैं, 2 source charges हैं. So how many electric fields will be there? Only 2. So अभी मेरे को resolution नहीं करना पड़ेगा, सिंपल या तो लॉ पैरेललोग्राम लगाना पड़ेगा या सिंपल हम जो रूल्स लगाते हैं वो लगा सकते हैं. Now if I'm going to say that this is -1, the source charge is here minus, so the electric field on the point P will be towards electric field. So I'm writing it as E1. Now if I'm taking this charge into account, its value, the electric field direction will be outside, because this is positive. So when you take positive, the electric field will be away. When you take negative, the electric field will be towards. Now the time comes for calculation. E1 is equal to 1 by 4 pi epsilon naught, and then Q means 3. Even you are taking, I have told you that no need of taking minus sign into account, because minus sign is utilized to show the direction. तो आपने वो दिखा दिया, इसलिए फिर से लेने की जरूरत नहीं है. So micro means 10 raised to power minus 6. What is the distance of point P from A, from the source charge? So it will be, from here to here it is 6 and here is 1. So direction will be 5 meter. So you can write 5 square. So it will be 9 into 10 raised to power 9 upon 25 into 3 into 10 raised to power minus 6. That means 27 divided by 25 into 10 raised to power 3 Newton per coulomb is the electric field due to first one. Now, for the second one, what is? Second one, it will be 9 into 10 raised to power 9 into 3 into 10 raised to power minus 6 divided by 6 and 1 7. So it will be 49. So it will be 27 divided by 49 into 10 raised to power 3 Newton per coulomb. So what will be the net E? Which one will be bigger? This one will be, because its denominator is smaller. So E net is equal to 27 by 25 into 10 raised to power 3 minus 27 upon 49 into 10 raised to power 3. What will be the numerical value? Unit will be Newton per coulomb. This is answer. So that's all for the today's class. If you have any doubt, I'm unmuting you. Please, if you can ask, if you want, you can ask any question for today's session. No?
So where is this in the textbook?
Is there any question?
Where is this in the textbook?
In the textbook, where is this topic?
Yeah.
When you open NCERT textbook, electric field is there. And this problem is given in example, inbox example. The triangle problem or dipole problem is given in example. Okay?
Yes, sir.
Okay. So that's all for the today's session. We meet day after tomorrow with the further topics. Thank you and have a nice day.
Yeah. Electric charges and fees. This textbook മനസ്സിലാവില്ല. ടെക്സ്റ്റിന്റെ പ്രശ്നമാണ്. CBSE NCERT. CBSE uses NCERT textbooks. NCERT textbooks are the highest, most boring textbooks ever. It's not so. അത് നാളെ ഇവളാണ് killer. അപ്പ പിടിച്ചോ
കണ്ണട ഓടിഞ്ഞു പോയിട്ട്
കൊണ്ടേ കളഞ്ഞാ കാണണ്ട, ആർക്കും വേണ്ടത്. അവിടെ കൂടെ പൊട്ടക്കാണാൻ വന്നേക്കണം. ആ